Okay, so we are going to use this table to find the rate of change, which is the same thing as slope, and we're going to explain its meaning. Do you guys remember doing this when we had a table? We look for the change in the y. What did I go do to the 76 to make it equal 152? What did I do to the 152 to make it equal 228? So I'm basically finding the difference between the two of them, right? So it looks like I added 76 on both of these. So this is my change in y. Now let's find the change in x. Well, to go from 3 to 4, I added 1. And to go to 4, from 4 to 5, I added 1. This is my change in x. To find my constant rate of change, CROC, which is the same thing as slope, I take the change in y, 76, and write it over the change in x, which is 1. And then it asks me to explain what this means. So I'm just going to look at the labels in my table. What does the 76 represent? In what units? So I went 76 miles. And what does the x represent? Driving time in what? Hours. So I went 76 miles in 1 hour. That's what that explanation means. 76 miles in 1 hour. If we were to write it as a speed limit, right, we would say 76 miles per hour, which is my rate. You guys should know that from doing the distance equals rate and time problems. Okay? So we just got all of that from that little table. So if that's me driving, am I speeding? Yeah, probably. I always speed. Okay. Find the rate of change represented in the table or the graph. So we're going to do the same thing. We're going to find the change in y, and we're going to compare it to the change in x. To go from 0 to 5, I add 5. 5 to 10, I add 5. 10 to 15, I add 5. -5 to -4, that's a +1. -4 to -3, +1. -3 to -2, that's also a +1. So my rate of change is 5/1. Does this make sense? Okay, what's happening over here? Plus what? +9, and again. +9, and again. +9. What am I doing on the x side? +10 on all of this. So my rate of change is my change in y over my change in x, which is 9/10. 9/10. Okay. All right. Now let's look at the average retail price of a computer. So this is the value of a computer represented in this table. So it says that we need to find the rate of change for the price of the computer. So what happened here? Did the price go up or go down? How much? So -800. What happened over here? +1. So this is the rate of change is -800/1. Remember that rate of change is the same thing as slope. So it says interpret the meaning of this. What does this mean? Well, we're talking about the value of a computer. So what's happening to the value of a computer? Staley, what's happening to the value of this computer if the change is -800? What do you think, Cheyenne? Yeah. the value decreases by $800 each year. Okay. Now, this was the average retail price for a computer in 1995. So this is pretty old information. But assuming that the rate of change was constant, predict the retail price for a computer that's 5 years old. So I'm just going to kind of repeat this table, and I'm going to go up to 5 years. So if it started at 2,000 and it decreased by 800 and it became 1,200, and then I decreased it by 800 again, what's the value? 400. So if I decrease it by 800 again, how much is my computer worth after it's 5 years old? Negative $400. The value of a 5-year-old computer is negative $400. So not worth very much, is it? Okay. Linear functions have a constant rate of change. Linear functions have a constant rate of change. We've talked about this. So determine whether each function is linear. So if it's linear, that means that the change in y over the change in x is going to be the same. And it might not look the same, but those fractions will reduce to the same value. So let's look at this first one. What did I do to go from negative 4 to 0? Add 4. 0 to 4, add 4. 4 to 8, add 4. 8 to 12, add 4. So I'm adding 4 for each increment on the y value. What am I doing for each increment on the x value? Adding 1, plus 1, plus 1, plus 1, plus 1. So the constant rate of change, which is the same thing as slope, for this is 4 over 1. So is this linear? Yes, because it says linear functions have a constant rate of change. So yes, because you can say its CROC, its constant rate of change, equals 4 over 1. Are we good with that? Okay. Let's look at the next one. What's happening here? Plus 4. What's happening here? What's happening here? Plus what? Plus 12. And here? Okay. 5. I'm adding 5 plus 5. So it looks like I have a constant rate of change, or my change is 4 over 5, which does that equal 6 over 5? So do I need to keep going? Have I already shown that it does not have a constant rate of change? Okay. So is this a linear function? No, because it has no CROC, constant rate of change. Are you okay with abbreviating that? Okay. We have a big old box here that says slope is. So I'm going to do a couple of things. I'm going to sketch a graph because I'm visual. And I'm going to tell you that slope is, remember that slope is the change in x and y. And we count it like this. We go up and then we go over. So that's a picture of slope. We're counting the slope or figuring out the slant of a line. Let's talk about some formulas. So the meaning of slope is just the slant of a line. We know that slope is also, we said, constant rate of change. We found the rate of change by taking the change in y over the change in x. We have some formulas that let us calculate slope. Y2 minus y1 over x2 minus x1 tells us what our slope is. And we have an equation that we learned in pre-algebra, y equals mx plus b. This is called slope intercept. And we know that m represents our slope. So all of these are things that identify our slope. We could also draw a table if you want. Do you want me to put a table in there to talk about the change? Okay. So we use this when we have 2 points. We use this formula when we have 2 points. We use this method when we have a table. And we use this method when we have an equation. Okay. So we are going to calculate slope given 2 points. That's what we're going to do next. So we're going to use that y2 minus y1 over x2 minus x1. So I want to tell you where those x1s, y1s, where that comes from. X and y is just an ordered pair, correct? So the x1, y1 is the first ordered pair, and the x2, y2 is the second ordered pair. Okay, so it may be helpful when you first start doing this to label the x and the y in your ordered pairs. So this is going to be x1, y1, and this is x2, y2. Because x comes first in the ordered pair, and it's the 5, 8 is my first ordered pair, and then the 7, 3 is my second ordered pair. Does that make sense? Okay. So it says in the equation or in the formula that I have to find y2 over y1, or sorry, y2 minus y1. So 3 minus 8. And I put that over x2, which is 7 minus 5. Do you guys remember doing this last year? We're in pre-algebra. So 3 take away 8 is negative 5. And 7 minus 5 is 2. That's my slope. I'm going to label my points again. You don't have to, but it might be helpful for you. X1, Y1, X2, Y2. So Y2 minus Y1, negative 4 minus 6 over X2, which is negative 5 minus negative 2. Notice when I subtract a negative, I put that in a parenthesis so I can see exactly what's going on. Because my brain tells me, well, that I'm already subtracting, so that takes care of the negative. That's what my brain does. It plays tricks on me. So I need to make sure that when I have a subtraction problem with negative terms, I put it in a parenthesis. And then what are you able to do when you have 2 negatives in a row? Do you guys remember? Turn it into a great big plus sign. So this really says negative 5 plus 2. Okay, so let's see. These signs are the same. So if the signs are the same, I'm going to add and keep. That's negative 10. And these signs are different. That means it's going to be a subtraction problem, and I keep the sign of the bigger number. 5 minus 2 is 3, and the bigger number is negative. So can I leave that as my slope? No, what should I do? Get rid of those negatives. A negative divided by a negative is a positive, 10 over 3. If I forget and leave those two negatives on a quiz or a test, what am I going to do? Take a point off. Yes. You want to reduce your fractions. Okay. I'm going to label it again. X1, Y1, X2, Y2. So Y2 is 2 minus a negative 9. Put that in a parenthesis. Over X2 is 3 minus 3. So the first thing I'm going to do is turn that minus a negative into a great big plus sign. So I really have 2 plus 9, which is 11. And 3 minus 3 is 0. Someone take their calculator out and do 11 divided by 0 and tell me what that reduces to. It gives you an error message. Do you guys know why? You can't divide by 0. This is undefined. We're going to talk about what that means in a second. This is undefined. Okay. Let's do the next one. X1, Y1, X2, Y2. Let's see. Y2, 4 minus Y1, 4 over X2, 6 minus a negative 1. Again, I'm going to turn my minus and negative into a great big plus. And 4 minus 4 is 0. And 6 plus 1 is 7. Someone take their calculator out and tell me what 0 divided by 7 is. 0. So this has a slope of 0. So I have this little thing right here that says Vux Oi, right? What does that mean? What am I talking about? Well, a vertical line has undefined slope, and it's written like x equals some number. I'll draw you a little picture. If I were to graph the equation, this is the equation x equals negative 3. That is a vertical line. That means it has undefined slope, and it's x equals a number. That's what VUX stands for. VUX. Vertical, undefined, x equals. Okay? Does that make sense? Vertical, undefined, x equals. So let's talk about the HOY. Let's see. So H stands for horizontal. And that O is really a 0. And y equals a number is the equation. So let me give you an example of a horizontal line. So if I were to sketch the graph and tell you that this is y equals 2. We've seen this already. I did this with you the other day when we started talking about functions. So HOY, horizontal, 0 slope, y equals is my equation. So I want you to know that when you see a y equals a number, that's going to be a horizontal line. It's going to have 0 slope, and you don't have to graph it. Like, you just know, right? If you see x equals, I want you to know that it's a vertical line, undefined slope. And we know it's undefined because you cannot divide by 0. All right? Okay. So we're going to work backwards. Remember that we know that slope equals y2 minus y1 over x2 minus x1. So I'm given the slope right here. I know that my slope is negative 1 over 2. I don't have all of the numbers that I need, but I can plug them in and figure it out. So y2 is 7 minus y1, which is r, over x2, which is 4, minus x1, which is 0. So this is, I just want you to think about, like, we just need to solve this to find out what r is, right? So this is a proportion. Do you guys remember doing this? Solving equations? Okay. So I really have 2 times the quantity, 7 minus r, equals, what's 4 minus 0? 4 times negative 1 is negative 4. So I'm going to write this right here, and I'm going to solve it. 2 times the quantity, 7 minus r, equals negative 4. So 2 times 7 is 14 minus 2r equals negative 4. What should I do next? Subtract 14 from both sides. That gives me negative 2r equals negative 18. And then I should divide both sides by negative 2. God bless you. R equals 9. Number 11. Same way. I'm going to set it up the exact same way. My slope, 5 over 3, equals x1, y1, x2, y2. All right, so 2 is my y2 minus 0 over r minus 3. So again, I'm going to set up a proportion and do some cross products. So 2 minus 0 is 2. 3 times 2 is 6, equals 5 times the quantity, r minus 3. So 6 equals what? What do I have to do? Distribute. So 6 equals 5r minus 15. What should I do next? Add 15 to both sides. So 21 equals 5r. Divide both sides by 5. And what does r equal? R equals 21/5. Or if you turn that into a decimal, r equals 4.2. Okay? You guys are going to do number 12 and number 13 as part of your homework. I want to do number 14. So word problem. According to the building code in Crystal Lake, Illinois, the slope of a stairway cannot be steeper than 0.88. So that means that the slope has to be 0.88. The stairs in Jane's room measures 11 inches deep and 7 inches high. Do her stairs meet the code? So if I were to turn this into a line, this kind of looks like a stair, right? How much do I go up? That's my change in y. And how much do I go over? That's my change in x. So how much am I going up? 7. And how much am I going to the right? How much am I going over? Okay. So what is 7 by 11? 7 divided by 11. 0.6363 repeating. Okay. So is it meeting that requirement? Meaning, is it less than the 0.88? Yes. If it was steeper than that, it would be greater than the 0.88. So like this is what a 0.88 would look like. Something steeper than that would look like this. Okay. So her steps are fine. Yes. Her slope equals 0.63 repeating. Okay. So your homework for tonight, you're going to finish the Google slide if you did not, and submit that. Then you're going to do number 12 and 13 from page 22 of your note packet. And then you're going to complete page 23 and 24. But I'll tell you what, I will make this. We have a quiz on Friday. I will make this due on Friday. This is due tomorrow, which is Thursday. I'll update Canvas to reflect that. And tomorrow we're going to do some like practice with slope and things like that to make sure that you guys understand slope. We'll do a domain activity. Maybe I'll make a breakout room tonight for domain and range. Okay. Is that all right? Okay.